Hi guys, welcome to the next video. So today we'll be talking about Hugging Face. So the question first is, why are we talking about it? Guys, see, most of you, if you'll be really working on LLMs, generative AI, it's little unlikely that you would use Hugging Face, but there is a very high chance also that you would use Hugging Face. Guys, see, why I'm starting out on a discussion on why we should know a bit about Hugging Face is that there are times when security and data privacy comes first. Okay, let's say you are uh, let's take any case, right? So let's take a case of translation, right? Let's say you have some secret recipe in your company, right? Secret patented thing, and you wanted to translate into other languages. Can you use a public API? No, you can't use a public API, right? So you would need something in house. So if you want to have a system in house, that's where Hugging Face comes into picture, and it works well, right? There are a lot of tasks for which LLMs like are not so good at it, but some models from Hugging Face might be performing way better than LLMs, right? There are various research papers also which convey that maybe some sort of domain specific classification task is there. There may be training a or fine tuning in LLM might be costly, but fine tuning in Hugging Face model is just free, right? So let's just talk about Hugging Face. So see guys, Hugging Face is a platform. Okay, now the first thing is it is an open source platform, and basically the idea is that it is a place where you will find a lot of models. Which models? NLP models, computer vision models, I think even tabular tasks are there. So let's open, this is Hugging Face website, and here you can find there is a section called models. So see, there are so many models, and see, the best part is you can basically sort it. If you want to have it multimodal, you're doing a computer vision task, NLP. So when it was started, it focused on NLP only, but now it has models for everything. Okay, audio, tabular, RL, and other. So see guys, this is the power, right? It has a place where you have so many models. You can just pick up any model, play around it. It's very simple. There is hardly any coding involved. We'll see the code afterwards as well. There is hardly anything to be done, but you need to realize that hey, there are these open source models. I can fine tune them, I can download them, I can keep them in my own environment, in an environment that's even free from the internet, right? So I can perform any task, I can perform any downstream task. And the best part is that there is no cost involved. The second best part is it's super safe to use. The drawbacks is you need a great machine, right? So you need to understand guys, even I was trying to say download a 8 billion parameter model in Google Colab, it failed. So for an 8 billion parameter, I think you need about 16 GB RAM minimum, and then 8 billion model might not perform super well in all tasks, but for demonstration purpose it might do. But the magic is that you need a big machine. But if you're working on something that's super safe, tell your company that hey, this is what I'm trying to do, we need to have an in-house machine that's probably 64 128 GB of RAM, and then just play around it, right? Have a model placed there, have a piece of code that runs. It's gonna be super safe, super cost effective, and yes, security is important. The next thing is that, as I said, that it has a lot of pre-trained models. Okay, now the next thing is transformers. Okay, now the thing is a library of pre-trained models. So I told you that it has a lot of pre-trained models. You can use it directly. We'll see in demo also. Now the thing is you can deploy, train, and fine tune as well using this platform. That's also true. And it is a community driven thing. Okay, now only thing that you need to know is that hey, Hugging Face offers a library called transformers. So I need to know how to use it. That's it. That's the only thing you need to use. Rest all you will learn while you will do it. So let me show you one demo. So let's say you're working on a classification task, right? You're working on a sentiment classification task. So see guys, only this much code you need. From transformers import pipeline, just initialize the sentiment analysis pipeline, and then you can parse it. So this is essentially called as zero shot learning, where you are not doing any pre-training, nothing, just loading a model at inference and just playing around with it. So let's say you have a sentiment analysis use case where you don't want the public data to be leaked to an API. So use it. See, it will get downloaded and it will give it a label as positive or negative. Okay, this is the power, guys. In merely in 3 to 4 lines of code, you are able to build a sentiment classification model. Before Hugging Face, you guys had to write a lot of code, but right now you can see there is hardly any code written. So guys, that's the power of Hugging Face. Now let's move to the next slide. The next thing is data sets. Okay, so guys, see, Hugging Face has a lot of data sets which you can leverage for your NLP based learning. The thing is that again, Hugging Face is an open source community, right? So do you want to maybe throw your data set at them? So in organizations, usually these kind of things are less used, but for practice, they offer a great variety of data sets. Do play around with them. The next thing is tokenizers. Okay. So guys, let's talk about tokenizers a bit. I hope you're able to see this slide. See, guys, tokenizing is nothing. You have text, you want to convert it into tokens. Okay, you're just breaking it into pieces. That's it. See, this hello world got broken into tokens. So you have a sentence that gets broken down into tokens. Those tokens get broken down into IDs. And then corresponding to every ID, you would have a dense vector. What is that dense vector? Word embedding vector, which we have seen in our previous lecture, right? We had a dedicated section of word embedding. So the thing is, that's how the flow is. Hey, you have a sentence. I'm going to break it down into tokens. Those tokens would get converted into token IDs, and those token IDs would get mapped to a dense vector. And what is that dense vector? It's a fixed size vector for word embeddings. Okay, and also there is something known as positional encodings, because this was basically this screenshot that I have is in context of transformers. So yeah, essentially you can skip positional transfer encoding for the timing. We'll see in later part of the course. So see guys, why we need to use Hugging Face: ease of use, state of art model, collaboration, flexibility. And guys, see, very importantly, as I was mentioning, right, safety is a very important parameter. So I think now you understand Hugging Face. Now you understand the fact that, hey, this is how I need to run up transformers library and pipeline. And anything guys you want to see, you can have a look at the documentation and stuff. In 3 to 4 lines, you are able to build sentiment classification. This is the code is for tokenization. I'm using BERT based uncased model for tokenization. See, it got converted into IDs. Now these IDs would have a dense vector, which is nothing but your embedding. So this much is fine for the introduction of Hugging Face, but now I want to talk about few more things. Let's also see on how simple it is to fine tune a model on Hugging Face. So see guys, I have a notebook for that as well. So essentially what we are doing is we are downloading libraries, importing libraries, and then doing data pre-processing, and we have a multi-class classification task. So you're able to see all you need to do is convert your data set into a data set format. Okay, this data set format is nothing but the format that is required by fine-tuning models in Hugging Face. Just tokenize it, split the data set, do some sort of padding. Why we need to do padding? So that our input length is of consistent length, right? Because for matrix multiplication, inputs and everything needs to be of consistent length. Then initialize the model and then start training. See guys, this is hardly any code, and all of this code is easily publicly available. Obviously I'll also share the notebooks and everything, but you guys are able to see how simple it is, right? I didn't finish the training because it was taking a lot of time and stuff, but in case you have a good machine and you want to try fine tuning a model. So see guys, the thing is, what is fine tuning? Let's just spend some time on this as well. What is fine tuning? See guys, fine tuning is basically the idea where you are not particularly changing the earlier layers of the model, but you're changing the last few layers of model. You're tweaking in the weights a bit so that it performs great on your specific task. That's it. So that's the part, right? That's okay, right? So essentially, let me spend some more time as well. Let me just see if I can. Okay, let me just see. See guys, the idea is that whenever you have a task, okay, first of all, try to see that can that task be solved by prompt engineering. If it can be solved by prompt engineering, it is good. That means, how can I use an LLM using prompt engineering for my task? The next question, the next thing is, Can I do something using RAG? So obviously we'll talk about RAG. It's fine. The next thing is fine tuning. For fine tuning, obviously there are a lot of things to know, but essentially guys, see, fine tuning is a costly operation. A lot of companies don't prefer to do that as well, right? It requires a lot of compute, it takes a lot of time, it requires a lot of experimentation. But right now you're able to see that using Hugging Face, I was able to fine tune a model very simply. All I need to do, there's nothing much that I need to do. All I had to do was basically just load my data set into CSV format. Let me just close it. Let me reopen it. Yeah. So all I need to do is that, hey, I need to have a data set. I need to clean it. I need to convert it into a data set format. Then I need to tokenize it. Then I need to split it into training and testing data, and then I need to pass it to the model, and that's it, right? Only 4 5 6 steps, and the code is also super simple. So guys, you're able to see how without writing a lot of code you can fine tune a model. You can try out playing with so many different models. Okay, the thing is, you can fine tune, play around so many models, try exploring a lot of different models for your use case. You can have a model that's completely in-house, super safe and stuff. And also guys, I think I made one LinkedIn post as well. There also I leveraged few of the models. Let me just see if I can show you. So guys, essentially this much knowledge for you guys is okay. See guys, you need to guys learn how to see the documentation and stuff. So once you're able to see the documentation and stuff, you will be able to tweak in. But you need to understand of how to use Hugging Face. Hey, there are so many models. I can use any model whenever I want, however I want. It's free of cost. Obviously the inference time would be large, more, if you don't have a great machine, but that's okay. So let me just see. Meanwhile, guys, please subscribe as well. At least 95% of the people who are seeing this video don't subscribe, so please subscribe. Also, I'll just show you. Wait. Hopefully, this post should be there. See, guys, here also you will be. Okay, wait. So I think, yeah, in this post as well, I would have leveraged some multimodality. So what is multimodality is essentially where you have text, image, audio. So see, there is image, text to text, right? So you can try out these models. If you would give it an image, it will generate text. So for every use case, see guys, I'll tell you how much Hugging Face you should know. So for every use case, you would have a model on Hugging Face. If you believe that, hey, LLMs are costly, maybe I don't want to try out on LLMs, I don't want to use a public API, then you can try out LLMs via cloud. If you don't want to do that thing as well, because you don't want data to be even getting transferred over your own network as well, then maybe you can leverage Hugging Face. Then you are like, okay, so how can I use Hugging Face? Using the transformers library, you can pick up and play around any model. How to look for models? Let's say you want to try out the newly released Meta Llama 3.1. See, you have a 4.5 billion model as well, 4.5 parameter billion model. So I'm not sure how much compute you would need to train use it, but you can use it. And now you are like, sir, from where will I find code? Just go down. Okay, I think there they haven't directly given the code, but yeah, see, click on use or use this model, and then click on transformer. See, you have gotten the code. Load the model directly. So guys, this is all you need to know. Okay, only you need to know is that, hey, I have a task, I need to look for a model in Hugging Face, I need to use this piece of code, I need to play around with it. That's it. There is no specific training, right? There is nothing, there is no formula that I can tell you. See, in sentiment analysis, all I had to do this. In multi-class classification, I had to do some sort of pre-processing and basically some minor code writing, right? Essentially converting my pandas dataset into dataset format that's essentially understood by Hugging Face, then doing a bit of padding so that my input size and stuff stays consistent, because for matrix multiplication, that's a prerequisite. And then just write the training code, right? Essentially, you can use it, right? Let's say you want to use any Mistral model, Mistral. So see, you can try out Mistral large instruct, you can use it directly. See guys, code and everything is available. You just need to copy and use it. Only thing be aware is that basically at times you need to pass tokens and all. Okay, so there are few models for which you want some authorization. Those are mainly LLMs because there is a layer of safety involved to it. So you need to pass some tokens and all. So you can generate tokens and all. I don't think that is very difficult. Still, if you want me to show you that as well, let's go to here. Let's go to settings. Essentially just click on access tokens. Okay, then you can just edit permissions. So this access token has permission to all these models. Okay, just you guys will understand. Only thing is that inside the pipeline thing you need to pass a parameter called hf underscore token. I think not hf underscore token, only there is a parameter called token, so just use it. That's it. There's nothing more to know about Hugging Face, but guys, see, this is an important tech stack. There might be a use case in your organization where you would use it. So just knowing this much is good, that hey, I have a problem statement. I don't want to use an LLM for some reasons. I want to try out on a Hugging Face model, download the model, play around it. If it gives wonderful results, chapter closed. The next chapter is that hey, I'm not getting great results. Can I fine tune the model? Yes, you can fine tune the model. Then maybe this model is not working well, I need to try out on other models. So it's an iterative process, right? There is no fixed a shortcut to knowing Hugging Face. Okay, that's it. Hugging Face is similar to like scikit-learn stuff, right? You don't know which model is going to work, you need to iteratively test it out. And then I showed you, right, sentiment classifications in 4 lines of code, and multi-class classification where you are essentially fine-tuning a model. So I think guys, this much is enough for today. So yeah, stay tuned in this series and please guys subscribe. Thank you.